Assalamu alaikum and good evening, everyone. Today we are going to start February-March 2024, paper 1-2. Let's start with question number 1. Which species contain the same number of neutrons as carbon-14 and the same number of electrons as sodium ion? Okay, so over here, number of neutrons would be 14 minus 6 means 8. And over here, there are 11 protons and a positive charge, which means 10 electrons. So we have to figure out which one has both. So if I subtract 17 minus 9, I'm getting 18 neutrons. And it has a 9 electrons, right? So A goes wrong. Okay, if you see, it has a 6 electrons. So B goes wrong as well. It has a 10 electrons and 20 minus 10 also gives you 10 neutrons. So C goes wrong as well. It means I'm left with only D. So D is the correct answer. 8 and 2 minus makes it 10 electrons. And 16 minus 8 gives you 8 neutrons. Is this understandable? Okay. Now question number 2. Which process has the largest enthalpy change per mole? Okay. So if you see, the net charge of nucleus is 3 positive and it is losing 1 electron. It's 5 positive, it's 6 positive, and it's 4 positive. So it means it has the highest nuclear charge, right? So it means to remove the electron from sulfur with the 6 positive charge needs the most energy. So this can be the correct answer among these. This one is the one which needs the highest amount of energy. Yes, B has a 10 electrons, but B has a 10 neutrons, right? And they ask you to the neutrons for this with the carbon, which has 8 neutrons. So that's why B is wrong. Yeah, the neutrons are wrong. Yes, Ishal. Yes, am I audible properly, Kef? So for question number 2, C is the correct answer. Okay. Now question number 3. Which sodium compound contains 74.2% of sodium? Okay, sodium carbonate, it has a formula of Na2CO3. Sodium chloride, it's NaCl. Sodium hydroxide, it is NaOH. And sodium oxide, it is Na2O. So 74%, which means that almost more than the 50% mass. So over here, if you work, 46 gram is sodium and 60 gram is carbon. So see, it's less than 50%, right? The mass of sodium is less than 50%, so it could not be 74.2%, so A goes wrong. Over here, sodium is 23 and chlorine is 35.5. So see, it's again less than 50%. The total mass over here is 106, the MR over here is 58.5. So see, it's less than 50% of this, so B goes wrong as well. Over here, it's 23 plus 1 plus 16. So it is going to be 40. So yeah, it is greater than 50%, but not that much because the total mass is 80. Over here, there are 2 sodiums, so 46 and plus 1 oxygen, which is 16. So it is going to be 62, right? So yeah, for this one, you can calculate and verify whether we are getting 74.2% mass of sodium or not. So 46, 56, yeah. 62 times 100. Can anyone calculate the percentage and tell me the answer, please? Okay, so you are getting 74.19%, right? So yeah, so C goes wrong and D is the correct answer. Is this understandable to all of you? Now, question number 4. What is the maximum volume of sulfur dioxide gas measured at room temperature conditions produced from 100 centimeter cube of diesel fuel containing 0.8346 gram of sulfur? Okay, so see, sulfur gives you sulfur dioxide. If you see over here, let's have a look at the MR of sulfur, which is 32.1, right? So if there is a 32.1 gram of sulfur, then the sulfur dioxide is formed as 32.1 plus 32, 64.1 grams, right? You can say it's a 1 mole, so 24 decimeter cube is produced. And over here, if you see, they have given you in centimeter cube, so you can make the ratio 32.1 gram actually produces 24,000 centimeter cube of sulfur dioxide. So if the mass is 0.8346 grams, then how much volume is produced? X, now calculate the value of X. So X is equals to 0.8346 times 24. So X is equals to 0.8346 times 24,000 divided by 32.1. Can anyone calculate the value and tell me the answer, please? 624. Okay, yes, 1 minute. So it's a 624 centimeter cube. So D is the correct answer. A, B, and C goes wrong. D is correct. It is because see how many moles of sulfur dioxide are there? 1 mole occupies 24 decimeter cube of the volume, but when you convert it into a centimeter cube, it becomes 24,000 centimeter cube. And why I use 24,000 centimeter cube instead of 24 dm cube? Because here all the answers in centimeter cube. So that's why I took the ratio of a more mass of a solid with the volume, and that volume is in centimeter cube. Is this understandable to all of you? Yes, Kev, did you understand? Now, question: which row shows the correct number of covalent bonds in a molecule of methylpropene? So see, methylpropene. Prop means 3 carbon, right? And it's a methylpropene. So 1, 2, 3 are double bond because ene and methyl. So there must be a carbon over here. So this carbon has a 3 bonds. This carbon has a further 3 bonds. The carbon in the center has all 4 bonds, and the carbon on the right has a 2 bond. So if you see how many sigma bonds are there, let me make the sigma bonds with the red. So with the green. So the green are the sigma bonds and the red one is the pi bond. So there is a 1 pi bond, and if you count the sigma bonds, 3 and 3, 6, 7, 8, 9, 10. So there are 10, right? No, 4 and 4, 8, 9. Yeah, there are 11 sigma bonds. And if you see, there is a 1 pi bond. So this makes C correct. And A, B, and D are wrong. Yeah, 11. Okay. Now question number 6. Aluminium chloride Al2 exists as Al2Cl6 molecules at room temperature. When heated to a high temperature, AlCl3 molecules are formed. What are the arrangement of the bonding pairs of electrons around the aluminium atom in the 2 forms of aluminium chloride? Okay, they are talking about aluminium chloride molecule. So Al2Cl6, if you draw it, it is going to be like this. one chlorine, second chlorine, third chlorine. And over here, and there is a two dative bonds, and it's Al2Cl6. When we talk about AlCl3, in AlCl3, it's like this. So see over here around aluminium, 4 bond pairs and 0 lone pair makes it tetrahedral. So tetrahedral are these two. These two goes wrong, which makes A and D wrong. Over here, 3 bond pair and again 0 lone pair, which makes it planar or trigonal planar. So this is correct and this is wrong. So C goes wrong as well. And B is the correct answer for question number 6. Yes, very good, Hassan. Now question number 7. The table shows the physical properties of 4 substances. Which substance has a giant covalent structure? So if it's a giant covalent structure, then it must has a high boiling point. So due to the low boiling point, A and B are excluded. Obviously, high boiling point. Electrical conductivity of solid, yeah, covalent. It's a covalent one, so usually it has a no electrical conductivity in its solid except graphite. In liquid, it also doesn't have a electrical conductivity because it's a covalent, so it does not have a free moving ion. So C goes wrong from here. And usually giant covalents are insoluble in excess. So we are only left with the D, one option, which is D. Is this understandable to all of you? Now, question number 8. At room temperature and pressure, water is a liquid and H2S is a gas. Okay. Water is a liquid and H2S is a gas. What is the reason for the difference of this state? So if you guys remember the bonding, you can easily identify that there is a hydrogen bonding between the water molecules, and over here only van der Waals forces of attraction between the H2S molecule. Oxygen has a higher percent, nothing to do with the ionization rate, the covalent bond. There is nothing to do with the covalent bond. Covalent bond can be accountable if there is a decomposition. There is a significant hydrogen bonding between water molecules, yes, but not between H2S molecule, yes. So this can be a correct answer. The instantaneous dipole induced dipole forces, no. The stronger is a hydrogen bond, right? So the correct answer is C for question number 8. I think it's clear to all of you. Now, question number 9. Okay. The enthalpy change for a reaction can be calculated from the values. The enthalpy changes of formations, the enthalpy change of combustion, bonding radius. The enthalpy change of a reaction is given by delta HR. Okay, they have given. Which expression could be used to calculate the enthalpy change of a reaction? Okay. So it is just, they are saying that it's from this expression we cannot calculate. It's just a statement, right? Okay. Now, over here, if you see, these are compounds, right? So okay. Now, listen very carefully. For example, as I have told you, and you know how to make the Hess cycle. If I try to make the Hess cycle by putting the elements over here, then I need to put the arrows like this. So over here, there are how many moles of ethane? 2 moles of ethane. So the enthalpy change of formation must be times 2 for this. And for carbon dioxide, it is also going to be times 2. for the enthalpy change of formation. And over here, they didn't multiply it with 2, so D goes wrong as well. Now we are left with the bond energies and enthalpy changes of combustion. Okay, so let's have a look at the bond energies. So for bond energies, no, 9 goes wrong or D goes wrong. Now for bond energies, okay, let me open the structure. So there are, if you see, 2 moles plus 3 moles of oxygen, giving you 2 moles of methane. I'm not making hydrogens, okay? 2 moles of carbon dioxide and 2 moles of water. So let's highlight the bonds which are broken with the red. So if you see, this bond is broken. This bond is broken. Okay, 1 minute. Now, this bond is broken, this bond is broken. And if you see, these bonds are broken. So see the formula of bond energy from the calculation, it says bond breaking minus bond forming. So these bonds are broken. So see, so it must be times 2, right? Because there are 2 carbon-carbon bonds which are broken. So it must be times 2, and the oxygen bonds must be times 3. And if you see in this expression, the oxygen bonds are missing, right? So that makes C goes wrong as well. So if we identified the A, C, and D are correct, so it clearly indicates that B option is are wrong. So B option is correct. Is this clear? No, how C is correct? If you see, the bond energy for the oxygen is not mentioned in the expression. See, so we have identified A, C, and D are wrong. So it means that B option is correct. And if you have to identify that is how B is correct, let's have a look over here. They are asking about the combustions, right? So for a combustion, if you see, the combustion products are carbon dioxide and water, right? So if this would combust it, there are 2 moles. So enthalpy change of combustion goes to be times 2 of C2H6. And from here, these are the combustion product. So only this is going to be combusted and this is X. So twice of enthalpy change of combustion of carbon dioxide as well. If you see the Hess's cycle, then this is one route and this is other route, right? So if I make the expression, then it is 2 times enthalpy change of formation of, enthalpy change of combustion of C2H6 is equals to X plus 2 times enthalpy change of combustion of carbon dioxide. So if I make the X subject, it is going to be twice of enthalpy change of combustion of C2H6 minus twice of enthalpy change of combustion of CO2. And if you see, this is correct, right? Now, question number 10. Which reaction has an enthalpy change equal to the standard enthalpy change of formation of propane? Okay, so let's make the equation for the propane. Propane is C3H8. So we need 3 moles of carbon, and carbon is a solid, and 4 moles of hydrogen gas. So we are going to get this gas. So see, these three are gases and this is liquid, which makes D wrong. And over here, the carbon is gases, is in a gas state, so A and B goes wrong. So C is the correct answer because the reactants and product must be in their standard states. Is this clear to all of you? Now, if anyone of you has any confusion till question number 10, please ask. Question number 11. One of the reaction in the rechargeable lead acid batteries is shown. Which statement over this reaction is correct? Lead is both oxidized and reduced. Okay. So over here, lead is 0. There are two oxygen. One oxygen has a -2 and there are two oxygen, which makes it -4. So it means less must have a +4. Now, if you see over here, it's a sulfate, which is -2, net charge is 0, which means lead is +2. So see, the lead from +4 turns into +2, which means reduction, and lead from 0 turns into +2, which means oxidation. So yeah, the first statement is correct. Lead is neither oxidized nor reduced, wrong. Lead is oxidized only, no. Lead is reduced only, no. Lead undergo both reduction and oxidation. Yeah, you have to practice. You have to manage the time. That's what it is. So always try to attempt the one which we can do in the first try without doing a lot of work and then move to the next questions. Keep the hard ones or the which were the taking the time at the end. Now, question number 12. KMNO4 is an oxidizing agent. Okay. It means it will undergo reduction, right? The reaction with the Fe2 positive ion is shown in the following ionic equation, element X and Y. What are the X and Y in the equation if it's balanced? I think this equation is so many times repeated, so you must remember that it is 1 and it is 5. That 1 mole of a magnet always react with the 5 moles of, iron 2 positive in the balanced way. So A, B, and D goes wrong, and C is the correct answer. This equation is repeated so many times. Or otherwise, you can do it by this way. See over here, MnO4 negative. Here, Mn has a +1 and it is turning into Mn +2. So if you see, so you can easily identify the +7 turning into +2, which means 5 electrons are gained. Now, if you see Fe2 positive, it is turning into Fe3 positive. So it is losing 1 electron, right? So 5 electrons are gained and 1 electron is lost. So it means 5 electron must be gained as well. So I have to multiply it with 5. So if you multiply with 5, you will get 5 moles of iron, 2 positive, losing 5 moles of iron, 3 positive, and losing 5 moles of electron. And these number of electrons are gained by the magnet ion. So that is how you will balance. So see, with the 1 mole of magnet, we need 5 moles of iron, 2 positive. Okay, now question number 13. Nitrogen and hydrogen are mixed in a reaction vessel. The reaction reaches equilibrium, giving a mixture of nitrogen, hydrogen, and ammonia gas. Yeah, okay. The mixture of a gas is present at equilibrium has a total pressure of 300 atm. Okay, number of moles in mixture. What is the equilibrium constant Kp? Okay, so if you recall the Kp expression, Kp is a partial pressure of ammonia square over partial pressure of nitrogen multiplied by partial pressure of hydrogen cube. So if I will put the values for the partial pressure is equals to mole fraction. If you recall the expression for the partial pressure of ammonia, it is equals to mole fraction of ammonia times total pressure. In the same way, partial pressure of nitrogen is equals to mole fraction of nitrogen times total pressure. Partial pressure of hydrogen is equals to mole fraction of hydrogen times total pressure. So let's put the values directly over here. So for partial pressure of ammonia, the moles of ammonia is 160. If you add them, what you will get? 0, 9 and 6, 15, 15 and 8, 20, 23, 5, 6, 7, 8, 9. Total moles are 930, right? So 160 over 930 will give us the mole fraction, and the total pressure is 300 atm, right? So times 300 square. Okay. Thank you, Hassan. Divided by partial pressure of nitrogen. Nitrogen is 180. Total pressure is, total moles are 930. Multiply by 300. And there is no power on nitrogen, right? Then hydrogen, 590 over 930 multiply by 300 and its power is cube. Can anyone calculate and tell me the answer? Till then, see, atm square in the numerator, atm, atm cube. So this would be cancelled and only atm and atm would be left. So it is going to be 1 over atm square, and then it is going to be atm inverse square. So here the unit is wrong. So D is not the answer. Yeah, can you tell me the value, Bani? It is 1.27. No, Hassan, I think your calculation is wrong because there is no such answer. 6.65 exponent minus 6. 6.65. Yeah, sure, check, Hassan. Exponent minus 6. So it is A, right? So B goes wrong, C goes wrong, and A is the correct answer. Yes, Hassan, did you get the correct answer? Okay, great. Now question number 14. A mixture of hydrogen gas and iodine gas is placed in a reaction vessel and of a volume V at a temperature T. The reaction, okay, is allowed to come to equilibrium. All the substance remains in the gaseous state. Argon is a gas then pumped into the reaction vessel. Okay, so what they are saying that when the equilibrium is established in this, where there is a hydrogen iodine and hydrogen iodide, they have introduced argon gas in it. The temperature in the vessel is maintained at T. Okay. How are the rate of the forward reaction and the partial pressure of hydrogen iodide at equilibrium affected? Okay. So if we are adding argon is an inert gas, right? So it doesn't affect the partial pressure of any gas. So it means that the partial pressure stays unaffected. This and this goes wrong. So A and C are wrong. Okay. Now, what happens to the rate of forward and backward reaction? So see, argon is not the part of the reactant as well. So it is not going to affect the increased rate as well. So B goes wrong as well. And D is the correct answer in this case. Is this clear to all of you? Because argon is an inert gas, it is not the part of the reaction. So it doesn't going to affect anything in this case. Now question number 15. Two experiments are carried out to study the reaction between zinc and sulfuric acid. Okay. Experiment 1, small lumps of zinc are added to excess dilute sulfuric acid. The reaction is carried out at a lower temperature with one other change. Okay, so they didn't tell you that other change in the experiment. So the lower temperature would lower the rate, right? Both experiment produces the same total volume of a gas and completed in the same time. So it means the rate would be same. What is the second change made in the experiment 2? A catalyst is added. If we add the catalyst, the reaction would be going to be complete in a lesser time, right? So A goes wrong. A greater mass of zinc is added. If we add the greater, yeah, one thing important, that lower temperature making the rate lower. So, but the reaction is completing in the same time. It means that the other factors would increase the rate. So catalyst can be the answer. Yeah. A greater mass of zinc is added. If we add the greater mass, we will get the more volume, not get the same total volume. So B goes wrong. A greater volume, again, if I add the greater volume, so there is a chance that the concentration, the rate would get greater, but we will get the more volume as well because the reactants amount is increased. So C goes wrong. Larger lumps further lowers the rate, so the reaction would not complete in the same time. So D goes wrong. Yeah. So the correct answer would be A, because that the lowering the temperature would lowers the rate, but still they are saying that the reaction is completing at the same time. It indicates that the other change would be the one which increases the rate. So that would be the catalyst only. And the product amount of the product is same. Is this clear to all of you? Now, question number 16. The relative magnitude of the property X of 5 elements is shown. Okay, they don't tell us the property. Okay, P, Q, R, S, and T are all in the period 3 and have a consecutive atomic numbers. Okay, what letters are not actual the chemicals? Okay, right. These letters are not the. Which row is correct for the element X and element of property X? So, if anyone recall, if we assume it's a melting point, because it's from, if we think of period 3, then it must be sodium, it must be magnesium, it must be aluminum, it must be silicon. So silicon does not have a lower melting point. Silicon's melting point is even greater than the aluminum. So C goes wrong. If we talk about the second ionization energy, no. It can be the electrical conductivity, right? Because these are metals and their electrical conductivity increases, then silicon, and then after silicon, we have a phosphorus. So the electrical conductivity decreases. So it can be an electrical conductivity. And see, element R. Yeah, aluminum has a 3 more electron. Yeah. So B goes wrong as well. So A is the correct answer. Very good, Hassan. Okay. Now question number 17. Element X is in period 3. Element X reacts with oxygen to produce solid Y. Okay. Solid Y is added to water. A solution with a pH of less than 5 is produced. Okay. So this makes acidic. So it's an oxide and it's an acidic oxide, right? Identity of X. Sodium forms basic oxide. Silicon form acidic oxide, but silicon doesn't dissolve in water, right? So B goes wrong as well. Sulfur oxides are acidic, but gaseous in nature, right? So D and A wrong. Phosphorus oxide, yes, it is the correct answer because phosphorus oxide P4O10 is solid. And when it dissolves in water, we get phosphoric acid, which is acidic. Okay. Now question number 18. This equation refers to the isolated gaseous species. Okay. The species fluoride, neon, and sodium are isoelectronic. This means they have the same number of electrons. Which order do their radii increases? Okay. So if you look at the periodic table, fluoride, neon, and sodium. Okay. So fluoride has 2 shells and a negative charge, right? Sorry. Sodium has a 2 shells, but it's an positively charged. So it means that its nuclear charge is increased, which makes its forces of attraction is stronger and its size smaller than the fluoride. Is this understandable? So the smallest one is sodium, that is for sure. So B and D goes wrong. Okay. Fluoride one has a negative charge, which means an extra electron. So the forces of attraction gets weaker. So it means it is going to have the largest size, smallest size. So it means neon is the one which has the size in between both of them. So in this way, if you see here, they are saying fluoride. So that makes A wrong as well. So we are left with the C because fluoride has largest and sodium ion has the smallest. Is this understandable to all of you? Okay. Now, separate samples of magnesium and calcium are added to an excess of dilute sulfuric acid. The observations are summarized in the table. Okay. Magnesium, vigorous reaction, bubbles of gas produce magnesium completely dissolves. Calcium, vigorous reaction, initially bubbles of gas produce, reaction soon stops and leaves most of the calcium unreactive. Okay. So bubbles are formed when you react a metal with the acid, right? Yes, am I audible now, Kef? So both are reacting with sulfuric acid. That's what I assumed. Let me tell you why. Because the sulfate solubility decreases down the group. So magnesium is at top and calcium is below. So when magnesium sulfate is formed, it is water soluble, but calcium sulfate is partially water soluble because its solubility lowers. So that's why the reaction would stop and most of the calcium stays unreacted. That's what I assume. Calcium is better oxidizing agent than magnesium. Calcium itself undergoes oxidation. So calcium is not a better oxidizing agent. We can't say calcium is a better reducing agent than magnesium. This can be an answer, but it is a general statement. And here they are talking about the specific reaction, which makes V wrong as well. Magnesium is more reactive metal. No, calcium is more reactive metal. Magnesium sulfate is more soluble than calcium sulfate. Yes, very good, Vinny. So D is the correct answer over here. Now, question number 20. Dolomite is a double carbonate, calcium magnesium carbonate, and can be used instead of calcium carbonate for treating acidic soil. Okay. The three statements all refer to the agricultural uses of these carbonates. Dolomite and calcium carbonate both are less soluble than calcium hydroxide. Yes, because calcium carbonate, down the group hydroxide solubility decreases and the carbonates are insoluble, right? So if the carbonates are insoluble, then this is correct. 1 mole of dolomite has the same neutralizing effect as 1 mole of calcium carbonate. No, because see, it is producing 2 moles of carbonate, right? And 1 mole of calcium carbonate, CaCO3, is going to produce only 1 mole of calcium carbonate. So its neutralizing effect is not same. So statement 2 is wrong. And if 2 is wrong, then you see A goes wrong, C goes wrong, and D goes wrong. And in this way, we can figure out that B is the correct answer. Is this clear to all of you? If anyone of you has any confusion till here, please ask. Now, question number 21. This question is about two salts, sodium iodide and sodium chloride. The two solid salts are separately added to warm concentrated sulfuric acid. Okay, this reaction we have studied. Over here, we are going to get just HCl, white fumes, and over here, we are going to get iodine, and the other product is sulfur or H2S or sulfur dioxide. Aqueous solutions of the two salts are separately added to silver nitrate. Okay, with this, I'm going to get white PPT with silver nitrate, and with this, I'm going to get yellow PPT or pale yellow PPT with silver nitrate. And then concentrated ammonia is added. The results are noted. So this white PPT gets dissolved and this yellow PPT remains insoluble in aqueous ammonia and it becomes aqueous. It gets dissolved to give you the clear solution. Which row is correct? Identify the one product formed from sulfuric acid. With sodium chloride? No. With sodium chloride? No. With sodium iodide? Yeah, H2S is formed and yellow precipitate. So with sodium iodide, iodine is formed, and with silver nitrate, we are not going to get colorless solution because yellow precipitates are insoluble in aqueous ammonia. So C is the correct answer. Is this understandable to all of you? If any one of you has any confusion till here, you can ask. Okay. Now question number 22. The diagram shows the process of adding calcium nitrate and strontium nitrate to a separate boiling point, boiling tubes, and heating them. Identical conditions are used. Okay. As the reaction proceeds, the water containing units will, okay. Yeah, because nitrogen oxide is formed, and nitrogen oxide are acidic gas, brown color gas. It turns the, which row describes the color change and identifies the nitrate that causes quickest. So the quickest one is this one, fast, and this one slow, because we have studied the trend that when we move down the group, the thermal stability increases. So calcium is top and strontium is at lower. Okay. So as they are acidic oxides are formed, so the gases NO2 is an acidic gas which is released, and so this gas is acidic in nature. So as a result, it is going to change the color to red, right? Because the acid shows the red color. So A and B goes wrong. Quickest, as we have decided that it's calcium nitrate, not strontium nitrate. So D goes wrong as well, and C is the correct answer. Till here, is this clear to all of you? Okay. Now question number 23. The equation for the three reactions involving chlorine or its compounds are listed. Okay. Here it's a +5 and it's turning into -1, +5 turning into -8, +7 and -1, 0, -1, +5. Which statement of these equations is correct? Equation 1 describes the formation of a compound which is used to kill bacteria in drinking water. Not at all. Equation 1 does not represent the redox reaction. Yes, it is. Oxidation number is changing, so B is wrong. Equation 2 describes the formation of potassium chlorate. No, it's decomposition, not formation, right? So C is wrong. Equation 2 and 3 both represents disproportionation reaction. Yes, in both, a chlorine is both oxidized and reduced. So yes, D is the correct answer. Is this understandable to all of you? Okay. So we are done with 23 questions. Now the leftover question we will be doing in our next class. And I think, I'm not sure, but next class, I'll try my best to take tomorrow. If not, then we will only going to have a one class on Sunday where we are going to complete it, but I'll try my best to do it tomorrow. Okay. Okay. So see you everyone. Take care. Goodbye and Allah Hafiz.